Namaste, my name is Major Shiva Kiran. I am here to speak to you on the topic of Introduction to Maps. Introduction to Maps is an essential part of the training program for undergraduate students as well as postgraduate students for understanding GIS, mapping, geomorphology and such topics. I come from an army background, having served in the army for a while, and then last 20 years plus I have been involved with mapping, GIS projects, teaching and training. So, here goes, and I am happy to be in front of you trying to present the importance of maps, and the first session will be on Introduction to Maps. The session flow will be as such. We will discuss in the maps the history of geography. See, geography also has a history, how maps evolved, and over a period of time, see, maps have been there since time immemorial. How maps have evolved, that is one part of the session that we have today. Second will be the glimpses of latest technologies in map making. So, everybody is understanding that technology is growing, rapidly growing, and there are various ways of map making now, and that we will try and give you an exposure to it, try to make you understand what are the various ways in which maps are being made today, the technologies involved, and give you an idea as to how you could use this for various applications. Next will be the application areas. We will also give you a glimpse into the application areas of maps, how maps are being used in various domains through some case studies and through some examples during recent times of COVID and such situations. We will try and share with you some applications which will enable you to understand that maps are being used in many areas, for many applications. So, that will give you an idea as to where you could possibly be using maps for your applications. Then we conclude with trying to understand what is the prospects for students like you. See, as map making, as professionals, we understand that maps are an essential part of our curriculum of this program of development methodology, but to students like you, how this could be useful, where do you come in, that is again about which we will give you a brief idea. See, the British ruled over us for a long time. The British in fact came in about 250-300 years ago. Do you know the first thing the British did? The first department they established when they came to India, it was Survey of India. So, trying to tell you the importance of mapping, that once if you go to an area, unless you understand the area, you will not be able to, let us say, control the area. That is what the British did to us. The British, in order to conquer us, in order to understand where our resources are, how they could be exploited, they first mapped the entire country. So, they carried out secret surveys for capturing newer territories of the country. They also realized the immense potential of our natural resources, like our forest areas, like our water resources, like our minerals, and once they identified all this, next step is what they built the infrastructure for exploiting this. A lot of people say British built the roads, the railways, etc. in terms of infrastructure, but all these were done with a ulterior motive of exploiting our resources. So, but then understand that map making was an essential part of British taking over India. That is how they could manage and control. So, if you really want to manage and control an area, mapping is an essential input. The British did it at that time, but since the British left, have we used map making as a tool for development process? That is something all of you have to understand. So, map making is not only to control, but to manage the resources of an area much better. So, some examples we will try and understand how this could be done. So, the point I was trying to make here was map making was there essentially from a long point of for many years, and people like the British used it to control and manage our resources. Please remember, the operative word here is where is the natural resource, where is a phenomena happening. So, for it to be known, the location is important. Map gives us that location, and the British used it to good effect, and in the days to come or in the past, mapping and GIS are becoming an essential part of our development agenda. Today, it is not just limited to maps. As you would understand, we will see the definition of a map in a few minutes from now, but when we talk of maps, today we are talking of geo information technology. See, there is information on a map and geo is a location part of the map. So, combined together, geo and location, this being called geo information technology, is also known as geospatial technologies. And what do these consist of? They consist of a system called Geographic Information System, which is more popularly known as GIS. We also have digital maps. Now, all of you have heard of Google Maps. India has its own version of BHUVAN, which is generated by National Remote Sensing Center. Then you have satellite remote sensing. So, satellites are able to capture images of an entire area and with which you can make maps. So, that is also there, and let me tell you with a sense of pride that India is among the leaders today in satellite remote sensing. Our satellites can provide you data up to 1 meter accuracy today, and then with that you are able to do lot of applications. We do not have to be dependent on anybody. So, erstwhile when we used to make maps, it used to be a physical effort, but now with satellite remote sensing you can get data much faster, much easier, and map making has become that much more easier. Then photogrammetry LiDAR. Photogrammetry LiDAR are other areas where by flying over an area you are able to get the maps of that area very precisely. So, difference between satellite remote sensing and something like photogrammetry is that in satellite remote sensing you get in terms of resolution. It is the little difference there is that satellite remote sensing gives you resolution, whereas photogrammetry gives you accuracy. This height information is also there, which is very precise in a photogrammetry kind of an effort. So, also LiDAR is a new system. It is about using sensors to collect data from the field. So, photogrammetry, LiDAR, satellite remote sensing, all these have revolutionized the way maps are being made today. Then you have the global positioning system, GPS as it is popularly known as. So, lot of places now GPS is being used. You have it in your own mobiles. When you say location sharing, that is what you do. The GPS gives you the location, the latitude, longitude, and that in turn gives you where you are. So, GPS is being used extensively for variety of applications wherever location based information is concerned. Policing is one example, hospital services is one example, in agriculture there are various examples. So, just name it a domain, a combination sometimes of GIS, GPS, photogrammetry is being used more effectively. But what is to be used where is the decision that the domain specialists have to take. Then you have other instruments called like total station, laser scanners, rangers. So, all in all you have a variety of systems today, variety of technologies today, which combined together are called geoinformation technologies or geospatial technologies, which enable us to make a map. And these maps in turn enable the decision makers to take decisions, and earlier the map data for it to be updated used to take a lot of time, but presently with all the technologies available it is much faster and easier. So, but because this session is about introduction to maps, we should see the basic definition of a map. If you talk of a basic definition of a map, it is a symbolic representation. It is a symbolic representation as is shown on the slide and self-explanatory of characteristics of a place which are drawn on a flat surface. As you understand, the earth is a globe, it is a spherical surface. Now, a spherical surface, for it to be put onto a two-dimensional surface involves certain processes. So, to put a spherical surface onto a two-dimensional surface and visualize, that is what a map is. So, a map as defined, a symbolic representation, a representation of a drawing of earth's surface, and it also defines the relationships between various features on the ground. So, these three definitions are what we would put across as a definition of a map. There are a variety of definitions, but these are the simple ones which define a relationship between the features on the ground and reduction of a spherical surface onto a two-dimensional surface. The history of geography, as I mentioned, it comes from the Latin word. So, it is the map is a Latin word which it references to the representation of the earth's features on a two-dimensional surface. See, as I mentioned in the beginning, maps have been there since time immemorial, also known as cartography. Basically, it was about drawing of maps, physical drawing of maps, and maps have been used by cavemen also. Sometimes when you see in the movies today, in the caves you have a small map showing directions. So, maps have always been there of part of our history. Travelers often used maps for navigation purposes. So, if you remember the story of Columbus, who traveled the entire world, but then in the attempt trying to discover India, he landed up in a different country in Africa and then started saying America and started saying that was India. So, likewise there were difficulties in using correct maps, generating correct maps. Then you required somebody like Vasco da Gama to discover India. So, there were archaic kind of tools earlier how maps used to be used, and traditionally India always used map making through the astrological I would say charts, and that you have in nature you have the sun to determine the direction of east, then you have the Saptarushi to determine the area of north, the direction of north. So, India had its own tradition, but then map making was used by greatest of civilizations like the civilization of Babylon, Greece, Rome, China and India. So, India always stood first in terms of, was ahead in terms of any technology, and map making also was an inherent part of our civilization. So, to put it very plainly, when we depict the earth's curved surface on a plane surface, that is a map. So, as I am repeating, the earth's curved surface, when we depict it on a plane surface, that is a map. So, inherently you would understand that when you put a curved surface on a flat surface, there are going to be some errors, because you are reducing a spherical map into a two-dimensional surface. So, that we will try and discuss in terms of accuracies, what you can identify later, but typically a map's definition is that a curved surface is being put on a two-dimensional surface, that much you should understand. Now, when you talk of maps, this has been done in a session earlier also, talk of maps, we are talking of topographical maps, we are talking of thematic geographical maps, we are talking of engineering maps and cadastral maps. Now, to understand topographical maps a bit, now topographical maps, as it's self-evident, as the name itself suggests, is a topography of the land. Now, again to just re-emphasize about a map is like a biodata of the land. Now, suppose you are told, you are asked to write about yourselves. How will you write? You will say, my name is this, my qualifications, my experience, these are my characteristic traits. So, also a map is depiction of the characters or the features on the ground. So, if you look at a map, it is the biodata of the ground. So, please understand that. So, without going to the ground, you can understand a lot by seeing if a map is properly made. Likewise, if a biodata is good, you can understand lot of features about the ground without really going to the ground. So, topographical maps, when you say topography, it is essentially the differentiating part about a topography and other kinds of maps is topographical maps have latitude and longitude, they have the coordinates, they give you the height information, all right, besides lot of other information, but the latitude, longitude and the altitude, that is the height information, the contours as we call them, that is a differentiating factor of a topographical map, but from any other map. Now, when we come to thematic maps, thematic map is like using one theme to depict a map. In a topographical map, you might have many features, like you might be seeing the roads, you might be seeing the water bodies, the forest areas, the mining areas, the habitation, many areas could be there, many subjects, disciplines could be there. Whereas, when you talk of a thematic map, you are focusing on a particular theme. It could be a mineral map, it could be a water resources map, it could be a forest map, things like that. So, you pick up a theme and with that theme you make a map. So, that is what thematic map is, which we refer to. We pick up a particular theme. Then, if you talk of engineering cadastral maps, engineering maps, see, when you talk about topographical map, it covers a larger area generally. When you talk of engineering and cadastral maps, they cover a smaller area. Typical example of an engineering map would be a map of a road, a map of a bridge, which shows precise measurements and alignments. A cadastral map generally refer to village maps, rural area maps. So, when you are talking of a rural area, you are referring, you refer to them as cadastre maps. Cadastre is called a land unit, cadastre. It is a small holding, like you have a farm holding, cadastre. So, that is called cadastre, and many cadastres coming together, we talk of, or we term it as a cadastral map. So, those are the types of maps, topographical map, thematic map, engineering and cadastral maps. The elements of maps, basically maps have some elements, some components, every map has some components. So, a map, as I said, is a depiction of the surface of the earth. So, what all elements are there, how you can depict them again is depends on your own skill and imagination. But basically there are some things which make the basic elements of a map, and these would be like a map should have a direction, it should show the north arrow. A map should have a scale, all right. and it should have the basic ambience or ability to understand the different colors. It should have a legend. So, having a direction, a scale and legend are called the basic inputs a map should have. Parts of a map, if you say, so there are different maps like I just now mentioned. A map should have an orientation in terms of direction, should have a heading, which area it is representing, then it should have a scale, it should have a legend, it should depict the boundaries of the area which it is showing, and it should have decent labeling inputs, it should have a scale. So, all these things make the parts of a map. Now, when you have a map in front of you, how do you start using it? For those who have some background of NCC and kind of, once a map is given, we say first find your own location on a map, where you are on the map. It is very, very important. So, first if you find out where you are on a map, then you can orient the map with the neighboring features which are around, and then try to use the map. So, in terms of orientation, first point is you have to identify where you are on the map. With that, you will be able to go on to the newer areas and explore. So, as I mentioned, Survey of India maps are the topographical maps generally of 3 scales. One is to 250,000, one is to 50,000, one is to 250,000. So, 3 scales, 250,000 as is being shown on the slide, one is to 250,000, one is to 50,000, one is to 25,000. So, 1 is to 250,000 is also called 1 degree by 1 degree, just for your information, and 1 degree on the map would mean covering about 108 square kilometers on the ground. So, if you are looking at a topo sheet cover on a scale of 1 is to 250,000, it covers an area of 108 kilometers by 108 kilometers. Roughly you can say 100 by 100, which is about 10,000 square kilometers. So, in every 250,000 scale map, there are 16 50,000 scale maps. Every 50,000 scale map covers an area of 15 minutes by 15 minutes. So, covering about 720 square kilometers as shown on the map. The third scale which Survey of India often makes maps is 1 is to 25,000. So, this is about 7.5 minutes by 7.5 minutes, covering about 1/4 of an area of 50,000, which would mean roughly about 180 square kilometer area. So, 250,000 which is 10,000 square kilometer, 150,000 which is 720 square kilometers, and 25,000 which is about 180 square kilometers. Now, if you want to have bird's eye perspective of an area, then you look at a map of 250,000. If you want little more detail, you look at 50,000, but if you want greater detail, you will want 25,000. So, these 3 scales, Survey of India makes maps of these 3 scales, you should remember. Now, when you have a scale of a map, it directly relates to the accuracy, because scale means accuracy. So, when you have a map of 250,000, that is 1 is to 250,000 scale map, the best accuracy you can get is 62.5 meters. You cannot get better than that. So, what happens is, the relevance of this is very important, that when you convert a paper map into digital form and then you try to make measurements on the ground, this is a variation which is acceptable error. That is, when you are creating a digital database from a topographical map of 1 is to 250,000, the error acceptable is plus or minus 62.5 meters. So, also if you are creating a map from 1 is to 25,000 scale, the error acceptable is 6.25 meters, which is plus or minus 6.25 meters. Now, try to look at your application areas. Let us say, suppose you are measuring or carrying out an agriculture survey, all right. So, that kind of a survey in a rural area which has lower economic value, a map of 1 is to 50,000, 25,000 also might be enough. But if you are doing a survey in an urban area where land is very, very valuable, you have to go much better than 1 is to 10,000 scale. Now, if you see in the slide, 1 is to 10,000 scale gives you an accuracy of 2.5 meters. So, 2.5 meter is also very, very valuable in an urban environment, especially precision is required. Suppose you are building a metro rail or you are building a road, so 2.5 meter would become very, very important. In that scale, in that situation, you might even require a map of a scale of 1 is to 1000. So, depending on your work area in where you are going to use the map, you will define the accuracy, and accuracy is defined on the scale of mapping, and scale of mapping comes from either a topographical map or the tools that you use, like initially I told you, satellite remote sensing, the photogrammetry, the GPS, all of them have various accuracies. So, when you compile them and make a map, that map will have an accuracy which should meet your requirement. So, even before you start a project, you decide on what tools you are going to use depending on the accuracy you require on the application. That you should keep in mind. So, this is the Survey of India sheet layout, like I just now mentioned, that in a degree sheet of 1:250,000, you have 16 50,000 sheets, that is smaller areas. So, the whole area, like I said, about 10,000 square kilometer is covered by one sheet of 1:250,000. But if you want more details, you have to look for a 50,000 sheet. You want more higher detail, then you have to look for a sheet of 1:25,000. All of these maps today are available in Survey of India offices, and let me also share with you, scale of 1:50,000, these maps are freely downloadable from the Survey of India website. 1:50,000 maps can be freely downloadable, and they have a wealth of information which can be used for a variety of applications. So, no matter which domain you come from, which area of specialization you come from, and after you do your undergraduation or post graduation, you will be able to use the 1:50,000 scale to very good effect. Now, when you look at the map numbers, like initially, I mean, we just mentioned some numbers, 56K, K11, K11 Southeast. Now, when you say 56K, it means it's a map of 1:20, 1:250,000 scale. When you say K11, it is 50,000, and then we say K11 Southeast, it is 25,000. So, remember, by seeing the number of the map, you can make out what scale of the map it is. The sheet number indicates the scale. The symbols on a map, when you see symbols on a map, normally we talk of a point, line and an area. So, these are the three things which are there on a map. So, point, line, area. So, if you look at a map, all your map data is restricted to these 3 points: point, line, area. Point means something like you would say a tree, a survey tree, all right, or a small habitation, or a post office or a hospital. That would be a point. Line example would be a road, a stream, that would be a line example. Area would be a larger habitation or a forest area which covers an area, all right. So, all your data on a map is either point, line or an area. So, some examples have been given here, and they are all depicted in various colors and using various symbols. So, once you start using a topographical map more, you will be able to understand the importance of the symbols and the colors, because they are all called conventional symbols, and the same symbols, same colors are used world over, so that there is a uniformity of understanding the map data. Contents of a topo map, basically communication, roads, towns, as I mentioned, boundaries, water, hills. The height information is also very, very important. So, a topographical map virtually has lot of information about an area, ranging from the communication linkages like roads, railways, water resources, forest resources, whatever resources are there on the ground are shown on the topographical maps. So, with that you would be able to generate land use maps, that is, which are the areas where cultivation is happening, which are the areas which are barren, which are the areas which have habitation. So, all these are very essential parts of development. So, if you want to increase agricultural production, you know which are the barren lands available, can you bring water to those areas. This is where mapping comes in as a tool to help the decision makers. Number of utility facilities are also available. As I said, the accuracy concept, when you talk of maps, the error roughly in some maps it is about 2.5 meters, some it is up to 6.25 meters. So, depending on the scale of the map, the error varies. So, it also varies in terms of horizontal accuracy and vertical accuracy. Now, digital maps, if you look at, as I mentioned just now, it depends on the map scale, that is scale on which the maps is generated, how you digitize, and if you enlarge the same map, the error becomes that much more enlarged. So, you have to be careful in terms of what scale of map you are digitizing, what tools are you using. So, all this together, when you say you bring together all these technologies, the high resolution satellite imagery with existing map, DGPS. DGPS again is an instrument like GPS, and then you are able to establish or create a map database which is acceptable, which helps you in creating a map database to enable you to take decisions. Just small example, the line in yellow shows the power alignment. So, power line project was being done here. So, this cuts across area of rivers, water bodies. The red areas which you see are the habitation areas. The black areas are the forest areas. So, depending on the areas on a satellite imagery, this tool was used to map out the alignment for a power line. Now, you see in a laboratory where let us say you are using maps, you can mark out the alignment here, and if suppose topographical map is an older map, you can overlay satellite imagery on this and make latest. Now, as an example, if you see here, the red area which are there, if they have increased in the last 10 years, it would show up on satellite imagery. That way the alignment would avoid those habitation areas. So, some small example. So, layers of information are there. Now, when you see a map, you are seeing all the information together, which is your roads information, your water information, forests, etc. But in a computerized environment like geographic information system, information is on layers. So, if a road person wants to see only layers, you could be able to see that. Forest person wants to see only forest, you could do that. That's strength of technology. So, maps are slowly becoming geographic information system, computerized mapping environment, whereby better decisions are being taken. So, applications, various applications across integrated land information system, digital photogrammetry and GPS total station. You name it, now GIS is coming into all domains, all applications. Maps are being extensively used from elections to agriculture to weather monitoring to water resource mapping. You just name it, maps and GIS are being used. So, some examples again done from the ground for mapping and surveying. Farmers, when it comes to agriculture, they are being shown their own boundaries. You know, revenue is system in our country is a big challenge. So, farmers are being involved and their agricultural lands are being mapped precisely. So, thereby itself, wherever the problems are there, they are able to discuss and sort out. Fields happening in the correction. So, once you handle the revenue data properly, a lot of challenges are sorted out. People are very clear, and then technology is enabling this today. So, from a conventional topographical map, older map, now we are moving on to DGPS surveys. LiDAR, as I told you, very accurate, it picks up data in minutes, and across a large area you can do it much faster, more economical, more efficient. So, all these tools are being used to generate good quality maps now. High resolution satellite imagery, like I told you, India is one of the countries which are pioneers in this, and we are able to generate high quality, high resolution, and all of you, whichever domain you come from, you should be able to use this. Some map applications I am just showing you, where all in urban environment you can map out across municipalities, across different areas. And then to tell you about, as I mentioned, we want to tell you about the students, that there is an opportunity for all of you in this. Whether you are a 10th class student, whether you are a graduate, whether you are an engineer, no matter what, in the GIS environment there is place for everyone. Some can create data, some can value add data, some can get into a managerial position to help in decision making. So, different kinds of roles are available for people with different education values. With that, I come to the end of this session, and I hope it's been useful. And using maps, what you can generate is a database which helps the decision makers take decisions, which in turn helps in the promoting development agenda of the country. Thank you so much.